So the popular ones we are familiar with the NumPy, Pandas, Matplotlib, Scikit-learn, TensorFlow, Keras, and all that we have. But I have given the responsibility of discussing only NumPy and Pandas. So it is very difficult to address, to clear the concept, to cover each and everything about NumPy and Pandas in this short span of 2 hours. So I will try to I will try to explain before you whatever is possible in this short span of time. So firstly, what is NumPy? So NumPy, it deals with multi-dimensional arrays, and we use some sort of mathematical functions also. So in NumPy array, especially in my worksheet, so I try to use some sort of this package of linear algebra also. So just to show you that how we use some matrix operations by the help of these linear algebras. So NumPy library is also clubbed with some tensor flows and to manipulate the tensors, whatever information we have according to that. So pandas also again used to manipulate the data. So it is not directly related to machine learning. So the data set is prepared before training also. So pandas is helpful when we have a big data set, and when we try to visualize some information from data set, or try to manipulate some information, try to remove some information, try to add few columns or some into that. So we are trying to use this NumPy and pandas. So what is the application NumPy? So NumPy in NumPy basically deal with some sort of arrays, and so one array, is generally it is it contains some kind of information, and generally it is experimental data or recording of some signals, pixels of an image, some information about the scans, radiological, especially radiological scan in medical decision making. So these are to be used. So NumPy arrays. So this is a again I explained you that is a package to the Python. So designed for scientific computing. So let me come to the actual thing. I hope this is visible to you.
Yes, sir.
Okay, this is visible. Okay, great. No. Okay, so it's visible. So all of you are familiar with this Google Collaboratory. So this is a online platform where we can use Python without downloading it. So start with the NumPy. So before starting this, first of all, my job is to import the NumPy module. So when I import the NumPy module, so first of all, I import NumPy. So we run is the NumPy as NP, and we run this. I
சோலாத்துக்கு
think
இல்ல
there
பாரு
is
கடையில் அந்த
some
கடையில்
noise in the
ஒன்லி
background.
சாட்டர்டே சண்டே மட்டும் தான்.
There is noise in the background. Okay, thanks. So it takes some time. So in between this, so when this tick will coming, so it means this NumPy module is imported in this particular this. So then after this, I come to the NumPy array. So let me take a very basic. So what is array? So I say that np dot array randomly I am taking it as 1 2 3, something like this. And I give it as name, let's say I give it name as a small a. And I want to print this. So my array is 0, 1, 2, and 3. So, similarly, by manual intervention, I can just create this array. It's a very simple thing that how we can create. So NP is just the extension. Now I want to create some kind of row vector into this. So my job is to create a row vector. So I can say I want to create a, why I am writing this thing, because after this lecture I will share this sheet with you and the same sheet with you, so you can run this sheet on your own Drive Google Colab platform. And that's why I'm doing so. Let me copy this thing from here, that what this vector says. So I can say np dot array. So let me take a big, take element 1, 2, 3, 4, 5, 6, and give me this name as a vector. Give this name as a vector. This name as a vector, and I want to print this. I want to print this vector. So print this vector. And I want to print that vector is equal to colon thing like this.
Sir, change the variable vector name, sector.
Oh, sorry. Thank you. Typo error. So this is my vector 1, 2, 3, 4, 5, 6. Maybe I need it to more. So in this way, so I can create some sort of, similarly I can create column vectors also in this same lecture. When we go along with this, we can go with that. How to create a matrix? We know that matrix, so this is a linear combination of vectors. Linear combination of vectors.
Some difference between a vector and arrays.
Excuse me, sir.
Difference between
Array,
array and vectors.
sir, see, let's say I have a given data set. In data set, first row I can say, if I have 100 rows, so 100 rows I can say 100 vectors, or 1000 columns I can say 1000 vectors. So in the similar way, you can also call it as a array also. So matrix is a kind of a array. So 1 dimension, 2 dimension, 3 dimension, it depend upon that. So I can, in layman term, I can simply say that array is a subset of a matrix. Okay. So now I want to create a matrix. I want to create a matrix. So I want to create a matrix of some order, and let me write it is np dot matrix. Np dot matrix, and so let's take first vector in this matrix is 1, 2, 3. Then I take comma, another vector, that is 4, 5, 6, and one more vector. Let me take 3 by 3, 7, 8, 9. So give me this name as matrix. Okay, so there are two ways if I write it like this, matrix and oh yeah. NP, oh sorry, it is not matrix, NP array. My mistake. This is a matrix. Matrix का ये रह गया था. So this is my matrix, and if I really want to print some matrix is equal to something like this, so in the previous like print like this, if I paid, I will get it like this, that matrix is equal to this thing. Now how to do this these kind of matrix operation? So in the similar way, let me plug in few matrix into this, few matrix, 2 3 matrix. We can add, subtract, and multiply these matrices in that way also. So one matrix is MP dot array, and it is, let's say, 1 2, same mistake I'm repeating, 1 2 3 4 5 6, and give me this name as, let's say, capital P. Then another is, let me copy this, NP let's say this is -2, this is 2 4, randomly I will change it, 1 6, and give it name as R. Name it as Q. And in the similar way, I plug in another matrix. Elements are randomly I am taking 2 6 1 2. So this is my three matrices, and now I am performing some operations. If I will perform some operation, if I perform some operation, and that operation is, let's say, first operation is R1 is equal to, if I add these two matrix, if I add these two matrix, so I can say it as NP dot add, NP dot add P comma Q. This is R1, this is my operation R1, and I want to print this like R1, and this R1 is, but this is P plus Q. R1 is P plus Q. R1 is P plus Q. And this is R1. So if I add, I will get something like this. And if so display is not so I can say it as a backslash, and so my matrix comes like this. Similarly, we can perform other operation also. Multiplication also, we can perform multiplication also likewise. But multiplication is not possible. Multiplication, number of rows, number of columns of first matrix is equal to number of rows of other matrix. So likewise we can do this. I'm not going to this thing in much detail, uh, in much detail, otherwise our time will be covered into that only. So other operation, I will leave this thing to you. Np dot subtract, np dot dot. You can multiply two matrices, something like operations that you can do. Now question is this, that if I have some array, how to compute sum, how to get the minimum, how to get the maximum from that. So let me copy this A. Okay, forget this. So let me copy this from here just to showcase, and I change the name. Let me give some x is equal to this, and my x is this array. Now I want to find what is the sum of, what is the sum, what is the sum. So I can say x dot sum, sum of these numbers. So what is the minimum? What is the maximum? What is the maximum? What is the minimum? So all these operations that we can perform on the same note, on the same note, instead of one single array, if I'm taking two arrays and I want to add these things in a matrix, because in matrix, whenever we perform to find the norm of a given matrix, in that case we add rows, we add columns, p norm, zero norm, one norm in a matrix we need. So give me this name y. So instead of this, let me take two vectors, small vectors. Let me take 1 2 comma 3 4. 1 2 comma 3 4, and this is y. So to understand this, I can say that if I want to do the column sum, if I want to do the column sum, so it is y dot sum. So this is y dot sum, and my axis, is this. So if I sum this, so if I column sum, so this is my axis is 0, then something like this. Now on the same note, if I want to do the row sum, if I want to row sum, so my axis is this. So in the same way, I can do row sum, column sum. So there is one special thing in NumPy, that in this question mark, suppose I can say NP, something I can do random. So this we will discuss, and I can say some function randomly I am writing and I don't know that how to pursue with this function and how to use this function. So if I use, so I will take the help of this new window. So this window will assist me and give one example also, that how to use this random array, whatever like that. So I am not going to discuss this thing because because we don't have much time into that. So one of the special features in this numpy, that if you don't know about much function, that how to pursue with that. So inside this parenthesis, how many parts you have, how to pursue with that. So this uh, compiler will assist you to do that. So if I can simply say, if I use this function random, no, I write here, so I know this. And if I simply say that this is a 3 comma 2 comma 2, let me write. So what is this 3 comma 2 comma 2? So if you see that we have 2 cross 2, 3 matrices, 2 cross 2, 3 matrices. So randomly they are picking up the values, they are picking in that way only. So this is how that we are doing the things in this. Now question is this, that how to deal with the 2D arrays, how to deal with 2D arrays, 3D arrays, how to get the shape. I hope you guys all know about this. And I will skip this thing because otherwise it will take much time into this. 2D arrays means if I have a 2 cross 3, 2 cross 5, some arrays like this, two vectors. In the array I have two vectors. Okay. Or you can say in a matrix I have two vectors, two row vectors. Okay, two row vectors. So if I explain it like this, two row vectors. So एक ले लेते हैं example. So let us say very basic, z is equal to this, and I can say my z is this array, and if I can say that z dot, what is the dimension of this? So this is 2. Dimension is 2 because I have two vectors. And what is the shape? Z dot shape. So it is 2 by 2. It is 2 by 2. Shape is 2 by 2. And similarly, we can deal with if I have a 3, 4 vectors, there I have two vectors. So I can find it like this. Now next is how to create arrays. So there are some inbuilt functions in this numpy that we can create by a function arrange. 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 So let me say I will take 3 and this give name small a. Arrange small a, and this is, if you see, it automatically take start from 0 to start from 0 to 10 elements. So it will automatically arrange. On the same note, if I will take same function and take the range something like this, 1 to, let's say, 9, and give it some name b. No, my b is this. So automatically they adjust. They start with 1, They start with 1 and within a difference of 2, they fix up uh, this matrix. They fix up this matrix. One more function, np dot linear space, that we call it as a lin space. Lin space, and this is 0, 1, 0 to 6. So give me this name as C, and my C is this. So if you see between 0 to 1, it creates 6 subintervals. So in the interval of 0 to 6, it creates 6 subintervals. And if I can say, let me create 9 subintervals, so it automatically adjusts. It automatically adjusts. Same function, same function if I use, but with some kind of conditional information, that between this 0 to this 9, and I say that, and my endpoint is false, not true. Now, what does it mean? It means that my endpoint is 9. 9 is not to be included into this, and say my endpoint is false. So in this way, I can create errors by using this linspace. Is a very useful function that we usually used. So I hope you get about this linspace. Then there are some common arrays. You know, in some common matrices, matrices of ones, matrices of zeros, and all that. I can create directly these matrices if I can say np dot matrix of ones, and let's say it is 3 by 3. Again, name, give it as a. So if I create matrices of ones, yeah, my mistake, apologies. So it create 3 by 3 matrices of ones, and if I want to take a null matrix, plug in the null matrix. So let me give this, then I can say matrices of zeros. Now my B is matrices of zeros. And if I will take a identity matrix, I will take identity matrix 3 by 3. So I'm using a feature np.I. So these are the special matrices that we are. Mhm. Oh, identity matrix is a, this is a, and what's about the diagonal? What's about the, suppose I want to create diagonal matrix. So I write it as np dot diagonal, np dot diagonal. Know my array, my plugin array. This is very important feature, array, and my array is, let's say 1, 2, 3, 4, 5. So I will get a diagonal matrix with the diagonal entries into this. So these are, then we have some random numbers. If I want to say random number, we already see in the previous. I'm not going to discuss all. Already we discussed this function np dot random dot rand. Already discussed this function. Then we come to data type. So what function is my data type function? Is this is a int, this is a float. So very basic. So I skip this. So let's come to some sort of plotting. Some sort of plotting in NumPy. When I talked about plotting in NumPy, so the one library that is matplotlib that I am using. So I import matplotlib dot pyplot, because this is something which is extension as plt. We'll see we use this function and we import this. So this is imported. This is imported. If some because I'm discussing NumPy and Panda, so these are very basic libraries. There's some libraries when we use image processing. In there we use some library of images already in the compiler. In that way we use some pip to call that libraries to install. No, when we plot this, so, so first of all, how to plot a line? Basic thing, plotting a line. How to plot a line? When we plot a line, so we have something like this. We have plot. We have some plot. Uh, let's say plt dot plot. Sum a comma b and sum a comma b, and I want to show that plot. If I want to show that plot, it is plt dot show plt dot show. Plt dot show. So it simply show, but line is not reflected. I am saying line. So in that case, I can say the interactive line between A and B. So between A and B, so A and B, let me take यहाँ लिखना पड़ेगा मुझे. So before this, so let me take A is equal to some array. A is equal to np dot array, and that array is 1 2 3 4, and b is equal to np dot array. So let me take it as 1.2, 2.2, 3.1, 4.5. So I will clearly get a line plot on this. So simply I create a line by simply, if I have two values, some x-axis and some y-axis, and if I want to plot a simple line plot, so the command is plt.plot. So it will clearly get. Now come to the 1D plotting. So for that purpose, generally what we have for this plotting, so this feature is very important, because when we visualize data, so we visualize data through graphs. So let's say I have some x, and this x is the information is in a NumPy. So I'm using this t 0 to 3 20. And my X information, if I display it before you, so they are taking between 0 to 3. So we have 20 subintervals. We have 20 values, you can say between 0 and 3, we have 20 values. On the same note, because I am doing plotting, so another function, if I am taking y, so y is something between 0 to 20, between 0 to 9, I have 20 subintervals, and this is my y. Thing is this, I want to plot. I want to plot this x and y. So my PLT dot plot x comma y. PLT dot plot x comma y, and you see I have a beautiful this. No, this is a line. I want to manipulate this, that rather this line, I want this is in a dotted form. I want this is in a uh, this is in some in different presentation. So let me say I will take it in some dot form. So I will get it like this, or I will take this is in some dotted line. So this is up to you that how you present this note. And no, this is a wrong thing. So line is like this. So similarly, we can use this function to, I hope you get similarly for 2D arrays. We can also do the same thing. Now, very important feature, that is slicing. The main role of data manipulation, whenever we have data, we manipulate, we remove, we add something. So in that way, so this indexing and slicing plays a very important role. It plays a very important role. So let's have a quick review on this indexing and slicing. So again, I am taking a array, numpy array, range, and this is let me take this is 20, and my a is array. Previously I already explained to you, simple array. Now I want to extract some element from this. I want to extract some element. If I say that I want the element on the first place, I want element on the 10th place. I want element last from the 10th. I count it last, then I'm using negative. So if you see, so these are the elements like this. I need this element, something like this. If you count it up, you will get that. So this indexing and slicing, for this you can use reversing also, but I'm not going to discuss this because already we then numerical operations, matrix multiplication, then elementary transformations. So I skip. So transcendental function, whenever we have sine and cos. So just have a quick view on this. So it is np dot. In some lectures, we carry code with us, and just to explain. So I usually uh, uh, type this thing because I want that it should be interactive in a way that everyone will understand. that how the live things will work. Sign of this value, and I will get it in terms of array. What is sign of this thing? Sign of this thing. What is log? Log. Log base 2. What is log base 2? What is log base 10? So these are transcendental functions that we use, but purpose is this, that to discuss some sort of the some sort of linear algebra. So in that way, we are using function numpy dot lin algebra. So let's just visit, just copy to save our time. Some this, let me copy this PQR, this, let me copy this first, and then we start. I will explain you about this linear algebra, that how it works. No, I want to first of all find the inverse. Find the inverse. So you know that inverse is not a possible for, because this is a matrix, is not a not a rectangular. Sorry, it is a rectangular matrix. But for it we need this. So first of all we import this. So for this, let me say from numpy dot lin algebra, numpy dot lin algebra import inverse. Import inverse. Okay. So I want to find P inverse. I want to find P inverse. So I can say that what is the inverse of this P? What is the inverse of this P? And this is also array. So I write it like this. I write it like this, that P is equal to, and P, this array is okay. When I plug in this, so I can say it is print inverse P inv of P. Some mistake. Okay, so I think this is singular matrix. They are saying that determinant is 0. Let me change this matrix. So that's what inverse is not possible. So this is the inverse of so this matrix. So directly that function will, similarly we can import determinant also. If I want to find the determinant of P, so same here, likewise same thing. I want to import determinant, and I simply write it like this. What is the determinant of P and all that thing, that we can do easily. So I skip this and leave this thing to you. How to find the eigenvalues and the eigenvectors. How to find the eigenvalues and the eigenvectors. So that we will do. Suppose I want to find the eigenvalues or the eigenvectors of a matrix. So I can simply say that my values and vectors. How to get the values and the vectors? So these are NP dot linear algebra, because eigenvalues, very important concept. It is eigen of P. Now, first of all, I want to print the values. When I print the values, I will get values. So this is some imaginary, in some imaginary. And similarly, I can say that I want to print the vectors. So so these are the eigenvectors into in statistics also. In statistics also, if I have a array, I want to find the mean, I want to find the standard deviation, and I want to find all that whatever we want. If I have, I want to find the mean. So this is the mean. Similarly, I want to find the median. I can find the median easily. I want to find the standard deviation. I can easily find the standard deviation. Very basic. Now come to polynomials. Sometimes it is very difficult for me to find the polynomials. So in case of this polynomials, so what actually we do? If I want to find the polynomials, so let's say I have simple polynomial, and the simple polynomial that I have, that is capital P is equal to NP dot poly 1D, and it is 3, 2, -1 and 5. I'm taking polynomial of degree 3, and the equation is 3x cube plus 2x square minus x plus 5. So I have this polynomial. So if I plug in this polynomial and I want to find the, first of all, what is the zeros of this polynomial? What is the zeros of this polynomial? So what is a zero? What are the roots? What are the roots? What are the roots of this? So these are the roots of this polynomial degree 3. We have 3 roots. Order, you know, it is 3. So there is no need to calculate. So these are some basic that we do. Now we incorporate these basic and take a case study. So what is the case study? Before starting the case study, so let me discuss this data set. So this is a simple data set. It is available over the web. So I have this is marks of a student. So gender is given, name is given, and the courses: maths, physics, chemistry, English, biology, economics, history, and civics. So these marks are given. So this I can say that. So I have vectors, and how many vectors I have? If you see that number of vectors that I have, they are 10. And if I in as a column vector, if I can see that number of column vectors are again 10. So let's see same data set. I will plug in into this. So first, this is a case study of marks. So first thing that we do, I will import numpy. Secondly, I will import the file. When I import this file, so what I do, I create a window in this console to access the data. So for numpy, from because this sheet is opened, so as np, then I import file from google dot collab import files. How to import? I say that uploaded is equal to files dot upload, files dot upload. So I get the upload button. I simply choose from here. No, I have already folder here, and the dataset that I showed to you is this CSV file. This CSV file. So first of all, I will load this data. I want to display this data, and I will load this data, and I give it name. That how to load? First of all, see this. So it is np dot load text, and my file name is this student dot this csv. File name should be same, and this is delimiter is equal to from this. Then my data type, so this is a string. My data type is string. Let me give this name, otherwise I will be in trouble. I need to write each and every time data. And when I display this, so this is my data that I see the CSV file. No, so this data is presented in array form. So first vector, comma, second vector, third, and something like. So this is the first uh, row, second row, third row, something like this that I have. No, I want to create a matrix. I want to create this a matrix so that I will easy to use some operations. If I add, the marks of John and Pooja, Mukesh and Annu, Jennifer, or I subtract the marks, or I compare anything if I want to do. For that purpose, I am creating a matrix. So creating matrix. So so let me take, there are two matrix. One I am taking matrix of I matrix one. So let me copy this, so it will make me easy, because it will make me easy. So matrix 1, so this is equal to NP data load student CSB delimiter. So what I do, I will skip, I will skip first row, because first row, so it is a text file. It is a first, it is a text file. So I first of all ignore that row. So I use it as skip row. Then how many columns I will use? I will use columns. So it is 3, 4, 5, 6. Because if you see in this data set, because these first are text files, 1, 2, 3. So these are text files. So I'm not using these three columns, because matrix, I am only putting the integer type or float type information. So 3, 4, 5, 6. 3, 4, 5, 6. I'm making two matrix. First matrix this, and second matrix this, and second matrix this. So first matrix this, and second matrix this, 3, 4, 5, 6. Now I will print matrix 1. So I will print this matrix. So I will get like this. So similarly, I will print another matrix, and I give it name matrix number 2. Uh, so there is no, again I am skipping first row, and instead of this 6, I am using rest column 7, 8, 9, and 10. So the matrix number 2, so this is my matrix number 2. Now I have two matrices. Now I play with these two matrices and perform the operations. Perform the operations. If I will multiply these two matrices, so what operation I will do? What operation I will do? For multiplication, I can, let me write that the result underscore multiplication of this matrix is equal to np dot multiply matrix 1 and matrix 2. Multiply matrix 1 and matrix 2. Now, or we can use a print command for this. We can use a print command for print multiplication slash, and multiplication is equal to this. Okay, something like this that we can do. Similarly, we can add these two matrices and do. Now, how to do the stacking for these two matrices? So this is that how we can do operations. So similarly, you can perform addition, np dot add. You can do subtraction, np dot subtract, and all these operations that we can do. Now we can stack horizontally, or we can stack vertically, one on the other. So how to perform these? Because these operations generally we are using into this. If I'm using some kind of stacking, So what I am doing, let me come to the horizontal stack. Horizontal stack. So it is horizontal stack. And this is equal to np dot h stack. H stack. So this is again a array. Matrix 1, matrix 2, shift enter. But I want to print this thing just to showcase you. So this is stacking. This is stacking one matrix, then other matrix. So these are the two, if I can say, stacking in layman term. You can say if I have a matrix 1 and matrix 2, if you see start with 55, 55 and this, oh, this matrix number 2, sorry. This is 2, print 2. 21 this. So this in layman term you can say is a augmented matrix. Stacking, it is a augmented matrix. One is matrix 1 from first four columns and from second this. On the same way, we can do this thing, the vertical stacking. We can do the vertical stacking. So for this, so this is vertical stacking. So my feature is V stack. So first 10 rows are matrix 1 and second. So we can club two matrices like this way also. This way also we can club that, we can play and manipulate. So these matrices, we do sequencing, we do statistical operations again, but to get the minimum value in matrix 1, but to get the how to generate some kind of functions. If I can say, what is the minimum value? Np dot min of matrix 1. What is the min value of this? So the minimum value. Similarly, you can get the maximum value, you can find the mean, you can find the standard deviation, whatever data, if whatever thing you can use some logarithmic function, you can use some transcendental function. If I can say, what is the log of this, np dot log, log base e of matrix 1, matrix 2, matrix 3, something like this. Sorry, matrix 1 and 2 I have. So that operations directly I can plug in and to get the information like this. So on the same way, on the same thing, so I'm taking some another case study. And take another case study. So let me copy this for you. Image processing. So image, I have any image, I already upload this, because already it is, the module is uploaded, numpy dot and numpy import as np. कॉपी करके जल्दी हो जाएगा. So let me copy one image library. So image from PIL import image. So internet is slow. So let me import image. So this is my image actually. So this is my image. In my presentation, I already told you that image. So what is image? It is a pixels. We can to understand the pixels in an image, we can use NumPy. So if I say image, give it name as a image, and it is a NumPy array. It is a NumPy array, and my image is a file. It is a PNG file. If you see, it is a PNG file, and I want to open this image. I will copy this. So it could be JPG, it could be PNG, and I want to display this pixels. If I can see, so see pixels. So other operations you can apply, you can do whatever you want to do from this data set. So NumPy I leave up to here. I have more to say on this image, how to convert this image into gray image, how to display that gray image, something like this. How to reduce the pixels in this image. So there is a low ranking approximation technique that we can use, and how to break this image into two, because if I have a matrix, so I can use SVD, singular value decomposition technique, and all that stuff into this. So my lecture of NumPy is up to here. Now I will start Pandas. Before starting Pandas, I want to ask if you have any queries, or we will take queries after this session, because already it is 7:10. So Pandas is left. So Abhishek sir, please advise what I will do.
Ask if you have any questions, you can ask
No,
right
no,
now.
if I will take questions now, so it will take after 8. Time I will take after 8, because still Panda is left to
No
discuss.
problem, sir. Take the question first.
Okay, great. So I welcome audience for the question. I will try to give your answer. वो हिंदी में कहते हैं ना, किसी के सवाल का कोई जवाब नहीं दे सकता, उसकी जिज्ञासा को शांत कर सकता है. So your curiosity, I will try to. Any questions? So I'm open with the questions. Whatever I discuss with you, you can ask.
I think no questions, sir. You
Okay,
can
so
continue.
great.
So till now there is no question.
Okay. So before getting into another concept. So, sir, I will share these files with you. I will download it, the code share with you. You can share it with the audience.
Okay, sir.
Okay.
Okay.
So next, I come to the Panda. So I am just fabricate some data. I create this data by my own, and just to make you understand about the pandas. So generally, what we do, researchers, or they are using these pandas for visualization purposes. They are using this to manipulate data, to add few columns. Generally, we add few columns to club two datas, to club two, like we for look that we are using in Excel. So we are using in this pandas also. So in this pandas, what I am trying to discuss, basically noting in two data set. In first data set, I will explain you that how we visualize our data using pandas by importing all that, how we do. And I take another data set and I club these two data set and get a single data set that we can use it for our analysis purposes and whatever we have. So this COVID-19 data set, very small data set, what I did, just go over the screen. I only pick five countries, not China, because China data is not reliable data. So I picked five countries. It is Brazil, Russia, Spain, UK, and US, and day-wise data. Day-wise, from the COVID start, from one country, let's say we have one patient, day 1 to day 132, day 132. So we have this small data set. Maybe this data set is big also. I am explaining this thing for five countries, but maybe this is for 200 plus countries also. So I pick only these five just to make you understand that how pandas are to be used for this purpose. So I so first, so this is a COVID-19. This is a COVID-19 data set. So first of all, what we do, first of all, let me import some modules. So I will explain the basics of Panda here only, because in Pandas we don't have much to say, because the functions are common. Because in Pandas we are importing data set, whole data set, and again we treat each column, each column or each row as an array. So all the your brackets are same. So first of all, I import pandas as PD. Then I import numpy as NP if I need some functions. Then I import for graph purposes, import met plotlib dot pyplot as plt. Okay, so then I print that modules are imported. So let me import these modules. That modules are used directly into this. Now on the same way, I will import this data set. Again, the same note, I am creating one button. From that, I will pick, in Pandas, you have a liberty that you can directly use the online CSV file. Online CSV file into this. For that, we have some different command into, for we have some different command. For that, we directly copy the URL and get, so that we will real time, and we can get, if data is changing on that website on real time basis, similarly your program is also changing on that. So I import file, it is same. I import files. So uploaded files.upload. So see, this button is created. I have this. So this is my data set. No, I will just import this data set. So in NumPy, it is NP. So in Pandas, it is PD. So I read this CSV file, and in NumPy it is text. It is text. No, here it is read.csv, and I have I will copy this. No delimiters. I will copy this because I will upload this whole data, and let me give this name as def. Now, what is my def? So this is my very small, and I will check what is the shape. So this is a matrix of order 5 cross 133. And what are my main features? So that I can say my features are head. So it will automatically, if I want to need only the first one, so it will only give me the first one, that countries, and first column is this, and the other column is 1 to 132 is the last column. 0 means only 1. So we have a liberty to, the shape is, so 5 cross 133 matrix. No, I will group, I will sum all. I will sum that. I will sum that. So shape I will already check. So I will aggregate this by countries. So I can say, give it as a corona data set, and that is equal to, I group by countries, and see, just to copy, because there may be some error in small and capital letters, and I will, aggregation means I will sum all. So when I sum, so I want to display, when I display, I will get something like this. Okay, so I will get some. No, I want to visualize data day wise. Day wise, I want to visualize this data. So in this we have a command. See, I have 5 countries, 1, 2, 3, 4, 5. So I will display the data of each and every country. LOC, first country is Brazil. First country is Brazil, and this is, I plot this. Then what are the levels of this data? No, what are the X levels? X level. So X level is it is the number of days. X level is the number of days, and what is the Y level? Is the number of cases. So this is X level. So this is Y level. So this is number of cases. Number of cases. What is the title of this? This, and the title is same name country, Brazil. So this is, if you see, from day 1 to this interval days 132, 133 days, the data is like this for Brazil. For other countries, I simply copy and change the name of country, and the second country is my Russia. Second country is my Russia. So same plot. Now come to a third country. For third country, my third country is Spain, then UK and USA, all are in capital. Spain, very interesting. Spain, then UK, then United States of America, USA. So from this data, you can analyze that how cases are increasing, how cases are decreasing, when cases are stable, in which day cases are more. This is just the visualization. Now, I want to display this data in intervals from this day to this day, from this day to this day, from this day to this day. So I want to display the data in intervals. In intervals. Okay, no. So this is still USA. Now I want to combine. I want to display combined graph. I want to display combined graph. So let me display combined graph. Let me display combined graph starting from Brazil. I want to display combined graph. See how to display combined. This is some different command. So this is Brazil. Then we have Russia. Then we have Spain. Then we have UK. Then we have USA. No, again my x-axis and y-axis. My levels, x-axis and y-axis. My x-axis is the number of days and y-axis is the number of cases in millions or in thousands, because this is a country where this. So then my legend. See, it is a combine and the color signifies which country is where only. And if you see this country, US has a more number of cases in millions. It has more number of cases in millions rather compared to rather compared to other countries. Now next is in intervals. In intervals, so let me copy one and then I explain you for first country, other countries that you can do it for yourself. In intervals, so for Brazil, I want to display the array first 33 days. First 33 days, and my title is this Brazil. In the bracket, I can say that day 1 to day 33. Day 1 to day 33. So it is a flat curve. For same for Brazil, for day 33 to 64. Because I am taking, this is a multiple of 32, and this is day 33 to day 64, and my display is this. On the same note, I can say that day 64 to day 99. Day 64 to day 99. And so on. I can say day 100 to day 133. 100 to 133. Similarly, we can do this thing for other countries also, that piecewise I can also discuss the graph, discuss the visualization in this way also. Now we see the rate of change. We will calculate the rate of change. So what is the rate of change graph of this? What is the rate of change? So let me say for Brazil, what is my, I'm using some different function for Brazil. It is derivative. It is the derivative, that differentiation, this. So title is Brazil. It is Brazil, then rate of change. So or I can say derivative. So this is the rate of change. Similarly, you can do this rate of change for Spain. You can do this rate of change for USA. You can use this rate of change. Let me check for USA what happens with that. So this is USA. You see that how turbulent it is. It is very volatile. That how, and another function, that what is the maximum infection? What is the, we find the maximum infection. Very important thing, what is the maximum infection rate of all the countries? So let me write some code lines on this. So I can see that the countries, so I'm taking it as an index. Then maximum infection, so whatever name I will take, that name is displayed. So this is again a array. So let me write C for countries. Let's see in, for C in countries. For C in countries, break. So we append this thing. Infection rates. We append corona underscore dataset dot loc, and this is C, rate of change, that is maximum. I will print.